Hello everyone, welcome back to the course on architectural design of ICs. So, we are basically discussing about the issues which are about to happen in digital circuit design. Okay. So, we do timing analysis for that to find out these several kind of things like false path, then clock skew, then clock jitter. So, we have to do apart from that, then there are like multi-cycle paths are also available. So many things are there which are related to that means and all the things we do, or all that means whatever timing analysis we do, that is to guarantees that the probability of circuit failure will be minimum 1. Okay. So, keeping that thing in mind, we do this timing analysis, right. So, again today we will see that some of the things which are not yet covered in the timing analysis. So, that how we can, that means correct the timing. Correct the timing means, suppose actually till now we have discussed, suppose the skew which is for synchronous design. So, what is synchronous design and what is asynchronous design? So, that we will see, and how we can manage this, or what is the tips for using when I will use synchronous circuit or when I will use asynchronous circuit. So, that we will see. If we do not use, so at that time what happens, that also we will see in today's class. So, the basic rules for timing, correcting the timing is that the flip flop should be clocked sequentially, synchronously. So, that means all the sequential element, what I said in the beginning, I said that synchronous circuit has more advantages. Okay. So, that means as all the flip flops are driven by the same clock, that means all are synchronous. So, data change is happened at the edge of the every clock edge occurs of a single clock. So, that is why here you see no flip flop changes state more than once per clock cycle, because every one is dependent on the same clock frequency or running at the same clock frequency, and flip flop propagation delay is more than the hold time delay. Apart from that, in the same design you never use, or you not never use it, you just try to avoid the mixing of the positive edge triggered as well as negative edge triggered flip flops. Okay. Means what? Suppose you have single clock, but sometimes you have used positive edge trigger flip flop, sometimes you have used negative edge trigger flip flop. For a single design, consideration of these two facts is not beneficial, or it basically creates the problem. Why creates the problem? Because at that time, at the synchronization, or that means the changes of the data, you may get problem at that time. Okay. So, then use of this edge trigger flip flops instead of latches. Why? Because latch is level sensitive, not edge sensitive. Okay. So, level sensitive means it is not that it depends on the only on the clock, then that means the highest priority at that particular circuit is clock. So, level sensitive means it depends on the clock as well as the data at the same time. Okay. No one is getting the highest priority among them. So, that is why always try to use edge trigger flip flop instead of latches, and always try to use this master slave deep flip flop architectures. Okay. So, this is the system consideration which you need to be keep in mind whenever you are designing your system. So, then what is this clock skew? Clock skew is what I said, that clock skew is that means whenever I am connecting to different flip flops. So, at that time it is not that every time every clock is getting that means the clock edge is basically occurring at the same time. Why it is not occurring at the same time? Because of the propagation delay which is associated for the clock pin to that particular element. Means what? Clock skew, suppose I am having the flip flop over here and another flip flop over here. Okay. So, this is connected through clock. Suppose if this is the clock, so the clock which is coming over here and the clock which is coming over here, they have a time difference. Why they have a time difference? Because this is a longer path to be traversing, need to be traversed for the clock signal. So, this will itself, this path is containing some of the wear delay. So, that means this clock will be delayed. So, if the age at this particular time, if this age occurs at this will not, that case it will occurs after some of the time at this particular point, after some time. So, this is basically the skew, clock skew, and when it is beneficial and when it is against us, that we have already seen, right. But the thing is that based on, as this is not, that means this age is not proper for this and this, that means the change of the data at these two particular point, there will be change, that means the change of the data that will occur at different time for this D1 and D2. So, which is not, means what? If this two data is changing at different time. Now, again suppose this D1 and D2 is connected to some of the logics, let us consider. So, at that time I will get error. Why I will get error? Because this is coming at different time, this is coming at different time. So, that is why I can get erroneous results over here. So, for that reason it is, that means advisable that you have to make that clock skew to 0. So, clock skew to 0 means the time requirement for this and the time requirement for this, that became, or that remains same. Okay. So, that is the concept of clock skew. So, then what is synchronous design and what is asynchronous design? In synchronous circuit, the state change occurs when the state input changes. The feedback elements may be wears or delays in asynchronous circuit, but in synchronous circuit the state change occurs synchronously, feedback elements are all clocked. Okay. So, what is that? If we take the example, so at that time it will be much more visible to you. So, asynchronous circuit means what? The circuit changes states only at clock edge. Okay, we will take the example of this. So, suppose I am having one asynchronous circuit, something like this. Okay. Now, asynchronous circuit, asynchronous input like this means, if I just connected it to two different D flip flop which is clocked at different head. So, at that time asynchronous input means it is coming at different time. So, that means at that time it will reach to D1 at different time, D2 at different time. So, that is why it is not, that means for the asynchronous input means if the input is not arriving to the flip flops at the proper time. So, at that time what we have to use? We have to use one synchronizer. So, synchronizer means what? You have to put another D flip flop, okay, another D flip flop, and then again that particular output will be connected to the other two flip flops which are connected over here. That means, suppose one particular signal input, if it is connected to several D flip flops over here. So, at that time the first thing is that you have to make that signal has to be passed through the registers, then you connect to each of the register element which is connected over here. Okay. So, this particular technique is known as synchronizer. Otherwise, what will happen? You may get some of the setup time or hold time violation. Okay. So, that we will see now. Again, that means now we will see those type of things where this kind of that means violation can happen. Okay. So, this is that means the same thing which we have already considered. Suppose how to or what is the that means need for this computation of this clock cycle time, because this clock cycle time is determined by the delay through this clock cycle. Okay. The signal must be arrived before the latching of edge, and if it is too late, it waits until the next cycle. So, now this is not the case. Suppose this is one combinatorial block and then we have two registers. So, we have already seen in the previous example. So, now if I consider this about this violation, when I can get the violation. Okay. So, suppose I am having this combinatorial circuit is something like this, and then again I am having two registers over here, right. So, now I am having the clock, this is my clock, okay. And then if I am having the skew, clock skew, so at that time this clock will be delayed, right. So, if this I is the input to the combinatorial circuit, okay, then because of this Q, suppose at this particular point whenever this clock is basically changing the data. So, at this particular edge, this is basically finding the corresponding positive edge, and what is the value over here I. So, the output should be 1 over here, because the output should be changed over here. Okay. So, if I just take the for this clock, whenever I am getting the positive edge, so at that time it will try to find out the corresponding data over here. Okay. Now, at this particular edge, as this is finding that okay, there is this values are basically changing, not changing. So, it will try to hold it value. Then again what is happening for this, okay, it is okay, this is clock bar, this is clock. So, at this clock bar what is happening? At this particular point, this particular point, as this data is changing, so again it will try to change its value. Means what? Because of this Q, the proper change in the data that is basically missed. Okay. So, because of these things happening, we are getting the violation. Okay. So, here you see, suppose there is a skew between the registers in the data flow, which is register A and register B. I gets the input value from register A and transition at Ck dash. Then the clock output O arrives at clock transition due to skew. To correct this problem can increase the cycle time. Okay. So, that is why if I that means consider the corresponding I, that means at this particular point, as this I is basically changing its data because of this Q, but you just consider at this 50% there is no change in the data, but because of this Q the data is changing at this particular point. So, data is changing at this particular point means it will create the problem to the output of this, which is basically creates the violation. Okay. So, though because of this q we can get at sometimes we can get this kind of thing. Okay. So, then again another example of this TPD minimum violation, which is the race through. Suppose this same kind of structure if you just see, and here because of this clock skew, the data changing at I that can happen early. Here what is happening? Here the skew, because of this skew the data is basically changing lately, but here you see because of the that means there is a huge change in the that means clock to clock bar. So, the data is basically changing very early. So, this is another TPD minimum violation, this is TPD maximum violation. But here you see here this input is basically dependent on the clock and this register B is dependent on the clock bar. Okay. So, based on that you can this timing constant that can be summarized as follows for any synchronous design. Okay. It will be combinational logic plus the delay which are associated with the sequential element. Okay. For each of the flip flop this condition has to be satisfied that T max plus T setup that will be lesser than the T cycle minimum minus T skew, and the T minimum will be greater than the T hold plus T skew, where T max is the longest data propagation path delay and T minimum is the shortest the data propagation path delay. Okay. So, these are the other things. So, in static timing analysis flow what we require basically, this is very much important. Why what we require whenever we are doing static timing analysis. So, at that time we need to design this or we need to that means consider this, read in the design, then the timing library, then the timing constant, then the delay annotation. That means, all this information if I provide to the EDA tool, then only that tool can give you the timing analysis report. Along with that, whenever we are doing this timing analysis, so at that time you have to follow this annotated delays, then IO path constant, then single cycle setup or hold time checks, then timing exception for false path, then multi cycle path, maximum delay constant and minimum delay constants. So, in the false path consideration what we have seen that we have to mention the tool that okay, this is the false path, we have to show from the beginning to the tool, right. So, here also that is why whenever we are doing that means setting up the constant file. So, at that time we have to set the timing exception that okay, this is the false path. So, you set the timing exception for this path or you check whether there is any setup time violation or hold time violation. Setup time and hold time violation can happen because of this skew or because of this jitter, this can happens. Okay. And then construct the timing graph based on this partition clock domain or ideal or propagated clock or case analysis. And then again this early arrival you have to, that means for this slack calculation you have to calculate this actual arrival time as well as required arrival time. So, based on that you can calculate this slack, okay, where this slack is very much important to get or to optimize the corresponding clock period. Okay. So, these are the important factors which has to be considered whenever we are doing this static timing analysis, right. So, then this is the false path example. Okay. So, false path example we have already seen. Now, another thing, suppose here we are having one circuit, right. So, it says that how would you meet the 10 nanosecond clock cycle time for this particular path. That means, when this clock cycle will be 10 nanosecond. So, as you see in this particular path, so this is resistor to resistor. So, there is one combinatorial circuit which is taking 6 plus 4 plus 2 means 12 nanosecond over here, and this particular path is taking 4 plus 4 is 8. So, clock period of 10, is it basically, can I do this clock cycle period as 10? If I do that clock cycle period to 10, so at that time as this time requirement is 12, so this circuit will fail to work. So, at the time what I have to do? I have to do a technique which is that means named as this retiming. So, what we see that here in this path it is taking 6 plus 4 plus 2, that means 12 over here, and in this it is having 4 plus 4. So, if I place this flip flop in this particular position, so at that time this position now it will take 6 plus 4 10, and here 2 plus 4 plus 4, that is 10. Okay. So, you see the flip flop has been just replaced to this particular position to make the balanced in these two paths, 10 over here. So, 10 over here. Now, we can do, or I can, that means set that cycle time as 10, but that means, is there any problem? Is there any problem? No, because after doing this, we can, as we have made this, we have made as these two particular structure is balanced in both the direction. So, now this will be this both the, that means things, or I can set the clock cycle to 10 nanosecond. Okay. So, another thing also what we can do, we can add the skew of 2. So, skew of 2 means if I put clock in the same direction to the data, so at that time what will happen? It will just reduce this clock period by 2. That means, whatever is the delay, so that will be minus. If I put the clock on the same direction with the data, so that means at the time delay will be minus, skew will amount will be minus, means what? At that time it will be 6 plus 4 plus 2 minus 2. So, that means it will become 10. So, at that time I can easily set the clock cycles to 10. So, that is another way of making this clock cycle period to 10. Okay. So, that means then in the previous case what we have done, we have used this retiming or reordering or changing the position of the flip flop, making the delay both the hand same, which is 10. In this particular case, we have used this, we have intentionally added clock skew of 2 unit of time to make this clock cycle of 10 unit of time. Okay. So, how we can do? That means, we can increase this clock skew, we can insert this delay cell, or we can add some dummy capacitive load, that we can do to introduce this clock skew in this particular path. Okay. So, this is the techniques by which we do to avoid the violation. Okay. So, this is the end of the this timing closure. It is not that, and every time I am telling you that this is not the things that this is the end of it. There are more on this, but it is not possible that all the things will be covered in this particular course. If you are more interested, then please let me know. With that, thanking you. So, this is the end of today's class.